I think I've shown you guys, or I've at least talked to a few people about the reason that we use synthetic division. It's another means to, well, you'll see here in a minute, how we can use synthetic division for working with polynomials is that you're able to take a nasty polynomial and divide out a term. And what I mean by that is, if I'm looking at this, what I'm calling a term, if I'm saying divide by x minus 2 or x plus 3, that's my term. Remember how we've always talked about what's the difference between a term, what's in parentheses versus it's 0? If the term is x minus 2, what's the 0? 2. My 0 would be 2. If my term is x plus 3, what's my 0? Negative 3. When you're using synthetic division, you are always, always, always dividing by the 0 of the term. Okay? And it's not so much, well actually, there's no division in this at all. It's a lot of multiplying and adding. Let me show you what happens. When you're using synthetic division, you're going to take the polynomial in descending order with placeholders and write down the coefficients. So x cubed 2x squared minus 6x minus 9, third degree polynomial, has 4 terms. Do I need any placeholders? No. Right? Coefficients. 1, 2, negative 6, and negative 9. And now you're going to make half a rectangle. Yes. And now you're going to divide by the 0. If my term was x plus 2 or x minus 2, my 0 is going to be 2. I put that out here. That's how the setup works for synthetic division. You do this each and every time when we synthetically divide. So here's what you do. This is very procedural. This process never changes. Numbers will. Okay? And it's a very, very simplistic way to do this. First thing you always do is you drop the first term here. That wasn't hard, was it? Okay. Now, what is 2 times 1? Like that there. Now add, going down, what's 2 plus 2? What's 2 times 4? What's negative 6 plus 8? What's 2 times 2? What's negative 9 plus 4? Okay. You're done. What happens here, what you've just done is basically a shortcut version of long division. What you've done here is you've started with, you had x minus 2 on the outside. You went into x cubed minus 2x squared minus 6x minus 9. What do you multiply x by to turn it into an x cubed? So you put it here. Distribute, you got x cubed minus 2x squared. You subtracted, you got a 4x squared minus 6x. X into a 4x squared is a, multiply out, 4x squared minus 8x. Subtract out, you got a 2x. Bring down the 9. You multiply it by 2. Distribute out, subtract out, and you get a negative 5. What is the negative 5? It's your remainder. Whenever you yeah, Lori? Where? I'm using what's called synthetic division, working with coefficients. It's going to take a couple examples, and once you see like 3 of them, you're like, oh, why don't I just do this all the time? Where? 2 times 4 is 8. Negative 8, or negative 6 and 8 is 2. 2 times 2 is 4. You multiply against these things to bring them up to here. Okay? Yes, ma'am?
Will the last term always be the remainder?
Yes, or it could be 0.
Alright.
So do we put over x minus 2?
I'm getting there. Hold on one second.
We always write down the first term.
Yes. So this basically tells me is that whenever you synthetically divide, the one thing that always happens is that you go down 1 degree. You started as an x cubed. You divided out a term of x minus 2. So basically you divide it out and you're left with this. This is x squared, 4x, plus 2. And then you had minus 5 over x minus 2. Okay? You get that remainder. Synthetic division is a fast way to tell whether or not something is a factor. It's a fast way to tell something is a factor. Because if it's a factor, are you going to have a remainder? No. Watch what happens when we do the x plus 3. Do the same thing. If my x plus 3 is my term, what's my 0? Negative 3. 1, 2, negative 6, negative 9. First step, always rewrite the first coefficient. 1. Multiply on the bottom, so negative 3 times 1 is? 2 plus negative 3 is? Negative 3 times negative 1 is? Negative 6 and 3 is? Negative 3 times 3 is? Do you have a remainder? No. So this becomes x squared minus 1x minus 3. That means that if I multiply these two together, what am I going to get? X cubed plus 2x minus 6x minus 9.
Wait, what's negative 3? Oh, never mind.
Where are we next?
I don't know how to explain it. This goes just like putting
Yeah, it goes down 1 degree from the beginning of the polynomial.
It goes one down.
So, hey guys, if we start with a polynomial of a degree of 7, and I synthetically divide out something that gives me a 0, that means I'm restarting with something to the 6th, and I continue on like that. I'm taking out degrees each time. Yes, ma'am.
So, on my answer, we include the x plus 3.
There's a reason why I'm writing that and getting there.
Okay, so we should write that.
We're getting
But
there.
this isn't our final answer.
We're getting there. I'm getting you to see something here. Because at this point, what times what's negative 3 you add together to get negative 1? Can you factor that? No, but could you use quadratic formula if you had to? You could. Basically, synthetic division is allowing us to be able to factor things you couldn't factor before. Because before, when we had a four-term polynomial, we would try and go by GCFs, and we couldn't get a common factor if I did that. But if I know a 0, negative 3, if that's a 0, I can factor it out. Laura, you had a question.
Oh, yeah. So the last number when you're dividing out is always the remainder?
Yeah, in this case it's 0, so is there a remainder? There you go. That just means that since that last number is a 0, that means that negative 3 was a 0, which means there was a term, x plus 3, that was factored out.
Okay, so then that x plus 3 replaces the x. I mean, the x cubed.
Yeah, because if you multiply x plus 3 times this, you're going to get what we started with.
Okay.
How it work?
How do you know that the first one goes with x squared?
What do you mean? Oh, for this?
Yeah.
Oh, what did we start with? We started with the 3rd degree. This becomes 2nd degree. That's all. Every time. Every time you synthetically divide out, you drop a degree. There'll be times where we're going to do this 3 or 4 times. And you're factoring this way because it's so much faster than any other method. Okay? That's the whole point of synthetic division, is to be able to factor upper degree polynomials because it's such an easy process. So you have it dividing out given terms, which means you have to write down zeros. Sometimes they might just tell you Well, here, let's just do one more. Do this one real quick. Take a minute and synthetically divide that. Excuse me. Yeah, there, get some water anyway. Ugh. Let's do this. Divide by the 0. 1, 0, negative 16, 1, and 4. I had to put a 0 in for the placeholder for x cubed because there wasn't one there. You have to have placeholders. You have to. Okay. Process. Drop the 1. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. So you're left with x plus 4 times the quantity. Well, I started a 4th degree polynomial. My new one will be x cubed minus 4x squared plus 1. And I know I cannot factor that any further. That's how this stuff is going to work.
I like this.
Okay? Synthetic division is a very easy way to factor. Alright. So when they're giving you a term, remember, divide by the 0. Sometimes they will give you the 0. And they're going to ask you to factor something, giving you a 0. How do I know that it's a 0? Because they say f of negative 3 is 0. So if negative 3 is the 0, what's your term? Very good. Remember, we talk a ton. I always bring this back up. If you're given a 0, your term goes to the parentheses. If the 0 is negative 3, the term is x plus 3. Back and forth. So we have 2x cubed, 11x squared, plus 18x plus 9. Again, this is a 3rd degree polynomial that has 4 terms. When we had that before, we just tried to group them and get GCFs. You'll notice if we do that, we're not getting anywhere. So we would just say it's not factorable. But now we can, because they gave us a 0. They gave us something to start with. So you start with your 0, negative 3. Half a rectangle, 2, 11, 18, and 9. What's the first step? Drop the 2. Don't drop the deuce. Drop the 2. No? Nothing, Jordan? Nothing? A little something for that one? Please? You snickered. Yeah, Lori, what's up? Yeah, how's that? Is that okay?
I am dying.
Excuse me. Drop down to 2, multiply, get negative 6, add 5, multiply negative 15, add 3, multiply negative 9, you get a 0. Hey, if they told you that negative 3 is a 0 and you don't get a 0, what happened? You done goofed. Go back and fix it. Yeah. So at this point now we know that negative 3 is 0. So its term is x plus 3. And now if I'm going to factor the rest of this out, I know now I'm at 2x squared plus 5x plus 3. Well, trinomial, isn't it? What's 2 times 3? What times what 6 you add together to get 5?
2 and 3. I switched it.
It's okay. So you factor it like you did before. 2x squared is 2x plus 3x plus 3. You got to factor by grouping then. Okay? Yeah, if it tells you to factor fully, then you do that. Because what's going to happen, you're going to have to factor fully, then eventually you're going to find all the zeros, and then eventually you'll take that, find the zeros, and draw the diagram via your dance move. Okay? I will warn you guys that on this test, a lot of times as we get into some of these things, there will be calculator, non-calculator in this one. So you have three terms, x plus 3, x plus 1, and 2x plus 3. Did it say factor or find all the zeros? I think it said find all the zeros, didn't it? Oh, okay. Factor. Well, we could probably find all the zeros then. What are your zeros? Well, we've got one at -3, -1, and -3/2. There you go. Factoring via synthetic division is ridiculously fast and efficient. Okay, it's very efficient, especially when they give you a zero to start with. Tomorrow you'll have to figure out your zeros. But guess what? There's a process to do that, and guess what? It's easy. Okay. Another way that it could be written is that I've shown you one way that they say that you're given a term, factor it. Given a specific one is a 0, f of -3 equals 0. Here it says 1 0 of f of x is x equals 2. So 2 is a 0. If 2 is the 0, what's its term? X minus 2. So it's telling you x equals 2 is the 0. So find all the other zeros. Well, what do? Well, you don't cry. You synthetically divide. I'm sorry. Third degree polynomial, 4 terms. We have all 4. Don't worry about placeholders. Be careful with your negatives. That's where you guys will forget. It's already happened today. One in the flex. Put a negative in. Go through the process. Drop the first term. 1, 2, 0, 0, 9. See how fast it gets to become? It's add and multiply. Add and multiply. Okay? So if 2 is my 0, my term is x minus 2. Here now I dropped it a degree, so what am I left with? X squared, 0x, minus 9, which means what are all my zeros? 2 plus or minus 3. Yes, ma'am. The rule is that it always drops out 1 degree. Because when you're dividing something out, if you think back to here, how did I turn the x into an x cubed? I had to multiply it by x squared. It's because of the rules of division. Because we're only dividing here by a singular term, the binomial with a degree of 1. And it's always going to drop it 1 degree. Every time you synthetically divide, you're bringing down 1 degree. Okay? All right, do this one. 10 is the 0. In this case, 10 is the 0. Okay? So I have 2x cubed minus 14x squared minus 56x minus 40. I'm going to find all of my zeros given the fact that one of the zeros is 10.
Oh, yeah, you do.